Let's get started. So welcome everyone. So thank you for coming. Welcome to the U.S. Research Software Engineering Education and Training Working Group Seminar Series. Today, we're very happy to have Subil Abraham presenting Building and Running Containers on HPC Systems, a not at all comprehensive talk. So first, I'd like to remind everyone that we do have a code of conduct that we ask everyone to follow. You can reference that here at this link. And if you are not yet a member of USRSC and you'd like to become one, you can join on the USRSC webpage right here. And if you're wondering, what is this USRSC that I'm talking about? We have Ian Cosden here, who's the chair of the steering committee for USRSC, who's going to give us a quick introduction before we dive into the talk. So go ahead, Ian.
Great. Thanks, Lauren. Thanks in advance, Subil. Really looking forward to the talk. So as Lauren said, my name's Ian Cousin. I am the chair of the steering committee for USRSC, and I just have a few slides to go over what we're all about doing. Hopefully encourage some of you to join if you're not already members. So we are a community-driven organization. We started as a grassroots, member-driven association of people who fall in one of these three categories roughly. So say the RSCs themselves, people writing, contributing to research software. It doesn't matter where you're from. Certainly we have lots of people at universities, but national labs, knowledge institutes, private companies, and more. If you're working on research software, it doesn't matter where you are. Folks interested in research software engineering careers, so this might be students looking to get in, or researchers to transition over to software engineers, and software engineers looking to get back into research, and those who just identify as allies who might manage, support, sponsor research software engineers. We have a four-pronged mission. Roughly speaking, trying to build a community, a professional community, so people can share knowledge, connections, resources, advocating for the increasingly important impact that RSCs have on research, providing resources to many different types of people, both supporting individuals, groups, making the business case, and diversity, equity, and inclusion. So actively trying to promote, engage, and improve diversity within our broader RSC community. So people from all over, lots of hotspots. We're at nearly 2,500 members. I didn't actually check today, but there's a chance that we are really close to tip over. So what goes on in the community? Look, we got a website. We send out monthly newsletters. We have a Slack workspace where most of the conversation happens. When you join, you get a link to an invite to there. Social media, we've got a job board, a YouTube channel where talks like this are posted and archived. Some of the resources that we have available that are becoming increasingly polished and put together. A few examples, so hiring, managing, retaining data scientists and research software engineers. We teamed up with the Academic Data Science Alliance to put together this 100-page guidebook of setting up data science and research software engineering programs in academia. The one in the middle here is getting started with the RSC movement. So within your organization, that was put together by the National Lab Empowerment Working Group within USRSC. And the last one is geared more towards students about what does this career path look like. Lots of working groups and other groups that have formed within USRSC. I don't have time to get into all of them, but they're there. They're in Slack. I can say very clearly they're welcoming and encouraging. And for example, the Education and Training Working Group is the reason we're all here. They put together the speaker series, and there's lots of other things. So if you see something here that kind of catches your eye, head over to Slack. It's pretty easy to find them. They're usually WG- in the name, and go and join in the discussions. We have lots of recurring events. We have monthly community calls. We had one yesterday actually talking about open source project offices, or OSPOs. There's a Funder speaker series that's on YouTube. DEI speaker series, more of these education and training work speaker series from the working group. And then we're at conferences, have panels, BOPs, workshops, outreaches. And we have a very own conference. So we had our first one last year in Chicago. Looking forward to our second one this year in Albuquerque in October. There's still an opportunity to participate if this is new to you, or just come and attend and get to hang out with other people doing this kind of work within research software engineering. So as Lauren mentioned, free to join. It's really easy. It's a simple form. You get signed up to the mailing list. We don't mail very much at all. Mostly it's just a curated newsletter and an invite to Slack. And we welcome lurkers. Please feel free to join. And I'll just leave this up as I close to remind everyone that Lauren mentioned at the beginning, but if you came in while I've been talking, that we do have a code of conduct. Please take a look at it. And in general, this is in chat, in questions that we ask, and of course in any USRC space. So with that, I will end and hand it back to Lauren, who will introduce our speaker, I believe.
I will. Thank you so much, Ian. So it is now my pleasure to introduce our speaker. Subil Abraham is an HPC engineer in the Oak Ridge Leadership Computing Facility in the Oak Ridge National Laboratory. He spends half his time solving problems for scientists who contact the OLCF help desk with issues they have on the supercomputers, the other half testing containers and advocating for container functionality on the various systems the OLCF supports. And the third half is spent doing various other odd work in user training and user advocacy. So with that, Subil, go ahead and get started.
Oh, all right. So let me share screen again and to take from start. Step 1. All right, that should be visible. And
I can see it. Thank you.
All right, cool. So good morning, good afternoon, good evening, everyone. I'm Subil Abraham, and I'm an HPC engineer at the Oak Ridge National Lab. So this is this is probably going to be the longest talk that I've ever given thus far. So I'll say up front, if anybody has any questions or clarifications, so like as I'm talking about things, feel free to unmute and interrupt me and ask, and that's probably the best way for me to the best way for me to be able to get to questions. I have the chat open, but I will probably, in case I miss anything,
we'll keep an eye on the chat. Yeah, we'll keep an eye on the chat as well, Subil, so we'll interrupt you.
Okay, sounds good. Let me get a laser pointer going. Okay, that'll be useful. All right. So this is going to be focused on the experience. This is going to be focused on talking about containers based on the experiences of supporting containers at the Oak Ridge Leadership Computing Facility. It is not meant to be an end-to-end talk covering every possible aspect of containers for every possible aspect of HPC. So it is limited by what I know, but I'm hoping that from the things that I do talk about, there are useful takeaways for you wherever you're working, for whether that is as an RSE supporting a set of users or as a sysadmin or supporting an HPC center. I hope that there is something that you get from that. So I've divided this up into sections. Oh, before that, is there any a fixed break in this seminar, or can I just keep going without breaking?
We don't have one scheduled, but if you need a break, let us know and we can do a 5-minute break for everyone.
Okay, I just needed to know if there was one schedule that I had to be mindful of. Okay, so the agenda it's split up into 5 sections. I'll go over the basic of what containers are, as it is understood broadly at a high level in the wider world outside of HPC. I'll cover a little bit about what the OLCF is, and which will help to provide context for the work that I was able to do in for containers on HPC, because it is informed by what the OLCF is. I'll talk a bit about containers and how they're used in HPC and how they can be useful in HPC, and then talk about building containers for HPC and specifically focusing on Podman and Apptainer, since that's what we use at OLCF. And then talking about like particularities that you'll run into when you're trying to build containers on an HPC system, and then talking about how you can run containers with good performance while also using typical HPC functionality like MPI and being able to use GPUs with your containers. So what are containers? It is, I will say up front, it will not solve all of your problems. So that is the first thing to remember whenever a user comes to you and says, hey, I want to put my thing in this container. It'll solve all of my problems. Um, at the highest level, a container, you can think of it as a unit of software that packages up all of the software that you want to run, as well that includes its code, as well as any additional libraries and dependencies that the application itself needs in order for it to run, and is able to run quickly and reliably with some level of portability from one computing system to another. So say, for example, I have a container file that you see on the left, also known as a Docker file that defines the structure of the container image. And in later slides, I'll go into detail about all of this. But for now, what the text on the left does is that it defines what a container image should look like and what the contents of it should be. And then on the right, you see there are commands, podman build, that will build your container image, and then podman run, that will actually run the container from that image. So in this case, I'm building a container image with CentOS Stream 8, and then I'm building that container and then running it to do an echo hello. So that's a fairly simple example of what you can do with containers. And the real benefit of containers comes when you start going into more complex applications. So there's many different implementations of containers. So Docker is one, Podman is one. There's also other smaller ones like Containerd and Kata containers. They can be run directly, as we saw earlier with the Podman run example, like you see over here. I'm doing Podman run to run my container directly, or it can be run with an orchestrator like Kubernetes, where it will orchestrate a number of containers running in order to perform some task all working together. And the benefit is your application is within the container, does not need to depend on anything else outside of the container. That statement changes when you start going into HPC, but we'll get there. And there are a few container runtimes like Singularity, Aptena, Charlie Cloud that were designed with HPC use cases in mind. It is a bold claim to say that a container once built can be easily ported from one computer to another. There's always going to be some work involved, especially when you start to look into the realm of getting the maximum performance out of your HPC, especially when it comes to HPC systems. If you're building a container for one HPC system, taking that container, copying it into the other HPC system and expecting it to work exactly the same way with the same performance, it's not going to work out that way. So reiterating on containers are not a panacea, but they can still be useful in quite a number of ways. And we'll get when I talk about containers and HPC specifically, I'll go over the use cases. And as mentioned before, we'll focusing primarily on like the lessons learned from my time getting containers running at the Oak Ridge Leadership Computing Facility. And this really and my focus will be on running these containers on shared HPC systems that a user is able to SSH to and then run their applications as jobs with a job scheduler. I will not be covering how to run containers on cloud or how to use cloud HPC or how to run with Kubernetes and things like that. That's not stuff that I have really have experience in. So it'll be focused more on the physical running containers on physical clusters and supercomputers that are managed by the folks who at your universities or at your HPC centers data center, and mainly focusing on Podman and Aptainer. So let's briefly let me cover what the OLCF is. It is one of the DOE Office of Science's computation user facilities. There are 3 of them, which you may have heard of. There's the Oak Ridge Leadership Computing Facility, which is where I work. There is the Argonne Leadership Computing Facility, and then there is NERSC, the National Energy Research Scientific Computing Center, that's housed in Lawrence Berkeley National Lab. And the goal of these computational facilities is to provide powerful computational tools for the purpose of open science. So if you have open science that you want to do, you are able to get access to these machines that with the sort of power that you can't really get anywhere else. The leadership computing facility part of our name comes from the mission that we are fulfilling, that is to enable capability computing opportunities to solve very, very challenging problems. So there might be a problem in medicine or astrophysics or engineering that you want to solve, and you can only really solve it with a large amount of computing power, be that a simulation, be that a machine learning. And you don't have the hardware. You as a researcher may not have the hardware or may not have access to the hardware that you need in order to solve that kind of problem. And so that's where a leadership computing facility can provide you access to that kind of computational power through a couple of allocation programs inside an ALCC. And if you write your proposal and it goes through those allocation programs, you're able to get computational power that you would not be able to get anywhere else, and you get it for free, because the goal is to support open science and to bring humanity forward and to bring science forward. OLCF has been home to a number of number one supercomputers in the top 500 supercomputer list. We've been doing it for a while now, and the most recent are Summit and Frontier. And the talk will be focused on lessons learned from experiences on Summit and Frontier. So Summit is an IBM AC922 supercomputer. It uses the PowerPC architecture. It has 2 Power 9 CPUs and 6 NVIDIA V100 GPUs. And the newest supercomputer that we have is Frontier, which is currently the world's fastest supercomputer, measured at 1.194 exaflops. It has 9,408 nodes, and each node has AMD hardware, so AMD CPUs, and an AMD Trento CPU and 4 AMD MI250X GPUs. And so the reason we need to talk about specifics of any of these systems, and also in your particular case, you will need to take into consideration the specifics of the HPC system that you're working with, is that they're very powerful, but they're very bespoke systems. And so if you have a bespoke system, you might have vendor-specific libraries that you may have to work with. And especially when you're trying to run containers with good performance, you may find that you might want to tie the vendor-specific libraries into your container. And so there is some trial and error involved. And so hopefully we'll talk about some general takeaways, but ultimately when you go to use containers, you'll be encountering some trial and error getting your vendor's HPC system or your vendor libraries working correctly with the container that you are building and running, or building and providing to the users that you're working with. So having said that, let's talk about containers specifically in the context of HPC. So why do we want containers for HPC applications in the first place, right? So we mentioned earlier, we talked about how containers are a unit of software that encompasses the application that you want to run, as well as the libraries that the application within the container needs. So this removes dependence on your host system's software stack. So if your HPC system does not have a particular library, you don't have to rely on the software team of that HPC system to install that particular library for you. With a container, you can take control of that and make sure that library is available for your application within that container. And you also have even beyond that, you have control over like system level libraries as well. Say, for example, you need a particular version of GCC installed at /user/bin/gcc. You will not be able to change that on an HPC system unless you are a very, very convincing person and you're able to convince the sysadmin of that HPC system. But for the most part, it is easier to just control that and control the version of GCC if you are building your own container, because you can specify what version of user bin GCC exists within your container. Another thing that I'm sure many of you may have had to deal with was very complicated build processes for whichever application you happen to have experience with. And sometimes it might just be easier instead of trying to wrestle the build system into working with the software stack that is available on your HPC systems, on the host nodes. It is easier if you can just provide what the build system wants in the container. And there is some, of course, there's still a rag on the difficulty of containers not being as portable as they are maybe believed. But there is still some level of portability that you can extract from your containers. It is not, it's not like, it may not necessarily be like take, copy, and paste elsewhere and it'll start running, but it's a lot easier than taking your natively built application and trying to get that specifically built on a different system. And another great use is that if you're working on an HPC system like Frontier or Summit, and you have a new person joining your team for whatever project that you're working on, it is easier to bring them on board if you can provide them the container with the application already installed on it so that they can get up and running. Perhaps they're just a domain scientist and they just want to be able to use the application to do whatever calculations they need to do. Making them go through the process of building a very complex application from source might be wasting precious time. So if you're able to provide a container for them, they can get started much faster. A great example of where this has been, like containers have been really helpful at OLCF was getting Google's AlphaFold running on the Summit supercomputer. AlphaFold 2, if you're not familiar, was a protein folding application based on deep learning that was very, very good at predicting unknown protein structures. But building it required the use of Bazel, which is Google's own build system. And the engineers who are trying to get this built on Summit spent a very, very long time wrestling with Bazel in order to try and get it installed natively on Summit because of certain hard-coded paths or certain hard-coded requirements within Bazel or within the build configuration files of AlphaFold 2. And again, this is where scientists are wasting time. They want to actually get to the science, right? So being able to use containers in order to encapsulate AlphaFold and then run the containerized version of AlphaFold 2 on Summit saved a lot of time, and they were able to actually get proper work done and were able to get a couple of papers out of it, and they were able to scale it on Summit as well. So it was not just stuck to, it's not like they could only run it on one node. They were able to run it up to, I don't remember, I think it was 512 or more than 512, 512 nodes. They were able to scale with the containers. So to give a visual overview of some of the things that I just talked about, of removing the dependency of your application from the libraries that are available on the host software stack. Say you had an application that needed to be linked to HDF5 and to MPitch and to CDF, right? Normally, if your HPC system has LMOD or something like that, you will module load MPitch and its CDF, HDF5, whatever, and then you would build your application, which would link to those libraries because they are now visible on the LD library path or the library search path. But you can, if you are trying to build it in a container, you can remove the dependence of the application on the libraries that are on the host itself. And instead, you put all of those libraries within the container and then link your application to those libraries that are within the container. And so that's defined by means of a container file or some definition file. And you can either, if it's possible, you can take this container and then plop it over to a different host and still run it, or you can use your container file to rebuild it in a reproducible manner on the new system. And you can reasonably expect that container to work in more or less the same way. And in this case, on this host, you don't have the HDFI library. And instead of trying to wait and work with the software team to try and get HDFI installed, you're already bringing the HDFI library with you with the container. So you're spending less time struggling to get the specific libraries that you need in order to get your application to run. So we'll talk about some terminology. The slides will be posted later, so you can have this as a reference for later on. But some things I want to hit on when I talk about a container builder, I'm talking about the software that is used to build a container image from a container file or a definition file or a list of instructions that define the container. The container runtime is the software that is used to start the container from the container image, so that you're actually starting and running an application. When I say container image, I'm referring to the file or set of files or the software artifact that is sitting on the file system and not doing anything. It's just, it's just some data in a structured form. The container is the actual running process that is started from the container image by the container runtime. So I just want to hit upon the distinction so there's not confusion when I'm talking about container image versus a running container. The OCI image and CIF files will cover that when I start talking about Podman and Aptainer in more detail. OCI image just means that is a container image that follows the OCI specification, OCI being Open Container Initiative. And they're multi-layered, not a single file. Whereas a CIF file, it stands for Singularity Image Format. It is a single file and not a multi-layered image. It is not compatible with the OCI specification. So some requirements that you will find that are important in running containers on HPC systems is that just like running a normal application, a container should also be running only with user privileges. You can't be giving, because it's a container, you can't be giving additional privileges to your user in order to let them run containers. That's bad practice. So, and many container runtimes are now built to only run with user privileges. So that is not really a problem anymore. You need to be able to build the container image on the HPC system itself. So often if you have like an x86 machine at home with Linux, maybe you can build your container there and then copy it over to your HPC system, which is also running x86, which is also an HPC, which is also an x86 architecture machine. Sometimes you might find that your HPC system may be ARM or maybe PowerPC, and ARM and PowerPC machines are not like common not common architectures that you see on home computers. So building it on a home computer and copying it over to your HPC system may not really be viable. So just like an application, just like an application you would normally build on an HPC system, a container, you should also be able to build a container image on the HPC system, on the login node or on the compute node directly. A lot of HPC systems require, or many applications that run on HPC systems require that they are able to use MPI. And this is both regular MPI and also GPU-aware MPI. And a container should not get in the way of being able to communicate a container should not get in the way of the application being able to use MPI to communicate and then scale up on your HPC system. In a similar way, the application within the container should also be able to use the GPU or any other hardware that might be specific to your HPC system. If that hardware is blocked from that hardware is blocked and it's not visible in the container, it's kind of useless. Because the application is not able to use your HPC system to its fullest capability. And hitting on again the fact that an application, whether or not it's in a container, would want to get the maximum performance out of your HPC system. And so a container runtime or whatever container format you're using, it should still facilitate your application to be able to get the kind of performance that it would have had if it were built and run natively. So let's talk about building the containers in HPC and some of the pitfalls that you will encounter. I put in a lot of disclaimer slides. I think I was working on this over several days, so I felt like I had to hit on it again and again. So yeah, a reminder that I can only speak of my experiences with Aptainer and Podman. There are many other container runtimes, and after this talk, if you are looking into containers, I encourage you to look at the other runtimes as well, and other runtimes as well, and make a choice based on what is effective for you or your users or your HPC system. I see a hand raised. Matthew Thompson?
Yeah, hi. I just wanted to make a quick clarification between
Yes.
Singularity and Aptainer. Are those
Yes.
effectively interchangeable? Because on our HPC we have Singularity, but when I do version, it says Aptainer version 1.1 or something.
So on your system, you're typing in Singularity, but you see Aptainer as the version.
And I understand that Singularity changed to Aptainer at some
right.
point.
So what happened is that there was Aptainer is a fork of Singularity. This is just based on my understanding, and now they're on two separate, but I guess parallel development paths. I think for now, at least, they're interchangeable. I don't know. I can't speak for the future because they're now being developed by two different groups. But Aptainer, I know that they still use Singularity as an alias. So when Aptainer is installed, they'll still create a link from Singularity to Aptainer. So people who are used to using Singularity or have scripts that specify Singularity will still run and will still use Aptainer, but we'll use Aptainer underneath.
Thank you.
Yeah. Also, some of these are fake. I made them up. My point is there's just a word salad of container runtimes out there, and you may find that one or a couple might be of particular use to you more so than the others. So I talked about the importance of containers without containers running without additional privileges. So currently, a lot of the ones that I've seen being used in HPC don't require additional privileges. So that's not requiring additional privilege is not a problem that you see anymore. And they're able to do that by making use of Linux user namespaces, and all of them to some extent support using OCI images. And OCI images are typically the images that you'll see on a container registry like Docker Hub. So if you go to hub.docker.com, you can search for different kinds of container images that are stored over there, and you're able to, with your container builder on your HPC system, you're able to pull one of those containers down and then either use that container image or build on top of that container image that you downloaded from that registry. And using Linux user namespaces, as far as I've seen, does not hurt performance. And it is especially preferred when you have HPC systems where you can't give additional privileges to ordinary users. Oh, oops. So let's go. So we'll talk in the next several slides. I'll compare and contrast like features of Podman and the features of Apptainer and how they are different, and then talk about specifics of each in the context of HPC systems. So for first thing to talk about is the way that container images are defined and then built by Podman and Apptainer. So Podman uses specific command invocations, whereas Apptainer uses more of a config file style. So what that looks like is on the left, you see a CentOS.container file, which is the input for Podman to build a container image. And on the right is a CentOS.def file, which is Apptainer's format is called definition files, whereas Podman's is called container files. And they're both of these on on the left and right are ultimately building the same container image, and they'll both do the same thing. They just, they have different languages to express that. So the from for both of them, what from does is that it will select and download a pre-existing container image from a registry. In this case, the registry that I am downloading from is key.io. And I am downloading CentOS Stream8. And on top of the CentOS Stream8 container image, I will build up the container image that I actually want with all the packages and things that I wanted in my own container image. So in the next few lines, you see these on the left for the Podman for container file, you see these run commands with the DNF install commands. And on the right, you see there is a section called post, under which I just call the DNF command. So this is what I mean when I said Podman has its own kind of language, where every one of these lines have to be prefixed by some command like from or run or entry point. Whereas with CentOS, whereas with the Apptainer, they are instead divided up into sections. Under each section, you can perform certain tasks. For post, for example, you're performing the same things that run is doing. And what it's doing here is that in the process of building the container, it is installing Apple release. It is performing the upgrade, and then it's installing wget and hostname. And so so each line so these lines correspond to each other because they're doing the same task. They're performing installs with DNS. And to build your container, you build with the Podman build command. For Podman, you specify the name that you want to give to your container image with -t. In this case, I'm calling it localhost myCentOS, and specify the file that you want to give as the input for building this container image with -f.
Subil,
yes.
we have a question in the Q&A.
Okay.
Do you want me to read it to you?
Yes, please.
Yeah. So what are the benefits of bootstrapping Docker on Podman instead of standalone Docker?
So I am not super confident and familiar with Docker being installable on an HPC system and runnable on an HPC system. I think from what I've understood and from experiences in the past, and also NERSC, who have gone all in on Docker, have gone all in on Podman. Podman seems to have better support for HPC setups, right? So this is where this is where my lack of experience comes in. I don't think Docker is super as useful as Podman is. So I see a comment in the chat that says Docker requires root access. I believe that's not really true anymore, which is why it's like it might be a less of a concern. Previously, it used to be a problem where Docker would absolutely require root access. Maybe it still requires root access by default. It's been a minute, but I feel like that's okay. I see comment from Carl Skipper that says rootless mode can be challenging, so which I presume that means for Docker. Whereas for Podman, rootless is kind of the default, right? So it's much easier to get up and going with Podman than it is for Docker. And Podman is one-to-one more or less with what Docker can with the containers that Docker can build. So you're not really losing anything from using Podman. You're probably gaining a little bit because Podman has a little bit more support and a little bit more focus, a little bit more of its attention if you look at the GitHub issues and stuff directed towards HPC. Yes, thank you. Asa says Docker uses a daemon, but Podman has a daemon-less architecture, and we don't like running daemons in HPC. Okay, this was I. Okay, so more other commands that you can do is you can
Sorry, we
if
do
you
have
want-
another question,
Yes.
but do you want to save it for in a minute, or do you want?
No, go ahead.
Go ahead. Okay, so how are containers different from statically linked applications?
So there are cases, I would believe there's cases sometimes where you're, if you're able to get a statically linked application built and running, that's usually fine. There are cases sometimes where you can't really build a statically linked application. I don't think, for example, that you could build something if you have an HPC system with a proprietary MPI with a proprietary MPI set of proprietary MPI libraries. I don't think that I don't think you'll be able to build a statically linked binary with those. And I don't and a lot of from a lot of software packages that I've built, they all build with, you have to load a module, and then once those modules are all loaded and available in the library path, you can build your application, and those are dynamically linked to the libraries that are available in those modules. There's quite a number of cases, I think, where you really can't build a statically linked binary to run on an HPC system. But that's my understanding of it anyway. Like the vast majority of applications that I've seen, especially when I'm working, helping folks build something with the help desk, almost all of them have been dynamically linked and required library that was visible that you needed to make available with module load something with lmod, or maybe sometime in the future trying to build that within a container. But for the most part, they've all been dynamically linked. Are there is there any other question?
Not right now.
Okay, cool.
Thank you.
So
yeah.
So other commands or other actions that you can do as part of building your container image is that you can copy files from your host system into the container. That's what the copy command and the files section does. You can set up environment variables to that will be present and set when you start running your container. So when you start running your container and you check for hello equals Sue, or when you check for the value of the environment variable, when you check for the value of the environment variable named hello, you will see that the value will be foo. There might be cases sometimes when you're having to support both Podman and Singularity. And imagine a case where you are a user, or you're supporting a set of users that want to build and run with Podman on one HPC system. Say, for example, NERSC uses Podman HPC, and so you have to build and run your applications with Podman, but they're also needing to run that they're also needing to build and run that same application on a different HPC system that only supports Apptainer. So there's ways that you can take the built container image from one and then convert it to the other, or you might decide that you might want to want to have definition files for both Podman and for Apptainer. So there's some applications like NVIDIA's HPC Container Maker that will generate the container file or the definition file for you based on, for example, HPC Container Maker has its own language, and we're building the same image that we've been building before with CentOS streaming. We're copying file 1 into the container image, setting an environment variable, we're running the DNF command, and we're installing certain packages. And then HPC Container Maker will output the corresponding container file format or the definition file format based on what you are requesting. And this might be useful. Again, your mileage will vary. This is not an endorsement, but more so like a heads up of this might be something you might encounter. Maybe this is a tool that could be useful to you because you are trying to support 2 different container runtimes with 2 different ways of doing things. A note also that talking about your mileage may vary. For example, the way that they generate the output for the container file or for the way that they generate the output for the container file or for the definition file might not be exactly the way that you wanted to. For example, maybe you wanted to install with DNS, but by default it generates yum installs instead. Another useful feature of HPC Container Maker is that it has some building blocks. For example, if you just call the GNU function, it will generate all of these. It will generate the yum install command that will install all of the GCC packages that you might want. And it has an OpenMPI building block, which generates all of this that will install OpenMPI for you for these specific configurations. But as mentioned, your mileage will vary. Maybe there's no guarantee that HPC Container Maker is going to be maintained into the future. They might not have the building blocks that you would want for the particular software packages that you need. Maybe there are bugs, you don't know. And so the point there is that make sure if you're supporting both Podman and Apptainer, test the container files and the definition files to make sure that they're both working the same way that they should be working. So the next thing to talk about is the way that the images are structured. So Podman has a layered image, and I'll go into that in detail. Yes.
We do have a few more questions. They're not directly related to what you're talking about right now. So if you'd like, we can wait till the end of the section, or if this is a good stopping point, we can address them now.
Let's wait till the end of the section. I think
Perfect.
Okay. Right.
Thank you.
So talking about layered image. So Podman has layered images, and Apptainer instead generates a single file. So when I say layered image, what do I mean? So when I am building my image, so this is the same example from earlier, what's happening is that it is actually effectively each line is creating a new layer on top of the previous layer. So this from line is creating this layer. This copy line is creating this layer. This environment variable line is not creating a layer that is actually inserted into a configuration file that is part of the OCI spec that then the container runtime will read, and then when it starts the container, it'll make sure that that environment variable is correctly defined. And then each of these DNF lines are generating each of these layers. So why is this important? Like what are the things that you should be mindful of when you are dealing with containers that are built up as layers like this? So just taking as another example, right? Say we're building up this image, right? Same CentOS stream we are creating, and then in the next 2 lines we're creating a file named file A. And the next after that we're creating a file named file B, and then the last line we are deleting file A. So in the layer form, what you'll see is that the bottom layer is CentOS, the second layer file A is created, and the third layer file B is created, and in the fourth layer file A is deleted. And notice that this is creating a new layer. It is not modifying layer 2, but it is instead creating a layer on top of layer 2. And what it will effectively do is that it will hide what's happening in layer 2, because since layer 4 came after layer 2, so when you look at it from the top-down angle, which is how container image will look like, or rather when you start running a container, you'll be looking at a view of the container image all squished into one flat layer. What you will see is that file A is missing because it has been deleted, because layer 4 supersedes layer 2. But this does not mean that the data in layer 2 has been removed. It is still there. So this container that we create here is what I'm showing here. So you can use podman save in order to save your container image in a tar format, and then inspect that tar format and inspect that tar file if you want to see the contents of your container image. And you can see there's still 4 layers represented by these 4 tar files that have these long names, and those names are because of the hash that is generated based on the contents of that particular layer. So these 2 layers refer to this is the layer where the file A is created, and this is the layer that file A is deleted. So your container still has data about file A. So if your file A is 3 gigabytes, if you delete that file A later, your container image will still have those 3 gigabytes. It's not gone anywhere because it's still in that layer. So what's actually happening when you open up those layer star files, you'll see that the layer in which that file A is created, if you open that up, you will see there's file A. But if you open up that layer where file A was deleted, you'll see a special file that's 0 bytes large and then has a special name that's called a tombstone. And that just tells the container runtime that file A should have actually been deleted. So make sure file A is not visible when it starts running. But the information about the data of file A is still there. So your container will look larger than what you think it should have been. So having multiple layers is something to be mindful of when you're building your image with Podman. There's ways to squish your Podman image down into one layer and then reduce the amount of space that it is occupying. You can reduce the number of layers during the build by combining a number of operations into one single run line. And another thing to note is that, if you're building large images, be mindful of the storage location that you're using in order to store your Podman images. And so that comes to the topic of the storage location of your Podman images, which in an HPC system, normally you have access to network file systems like NFS, GPFS, and Lustre, but you can't store Podman images. You can't store Podman images on those file systems. If you try to set your backing store as a location in NFS, GPFS, or Lustre, and you try to build an image with Podman, you will run into an error that looks something like this. This is because OverlayFS is a software utility, which is what allows you to provide a single uniform view of those multi-layered images. That is not supported by these network file systems. So you have to set your backing. You have to set your backing store location as at a location that is not NFS, GPFS, or Lustre. So the way you can do that is that you can set a file. You can set up a file called storage.conf. Either you can do it in your own home directory, or you can have your admin do it for everybody in etc containers storage.conf, where you specify for a rootless storage path, you specify a location that is on a local file system that is not shared between multiple nodes. Of course, what this means is that if you have an HPC system with multiple login nodes, if you log into a login node, you build an image with Podman, you log out and you log into a different login node, that image that you built earlier is not going to be visible because that was built and stored locally on a different login node. Yeah, and so since it's on a different login node, you have to make sure that if you want to continue building on top of that previous image, you need to go back to the same login node. So what happens? So because Podman images are not, are not visible across multiple nodes, what do you do when you want to actually run your container at scale, on multiple compute nodes, right? It's all the compute nodes cannot see your Podman image because the images are not stored somewhere that is shared between all those nodes. You need to go through the process of taking that image, converting that to a tar file with the command podman save, and then you have to copy it over to the compute nodes, and then use podman to untar those tar files, and then recreate the container image on each of those compute nodes, and then start running that image, and then start running the application that is within that container. And this could potentially take a while if your image is particularly large. Podman HPC is a wrapper that was created around Podman to automate this process. It was developed at NERSC. It's primarily working on Perlmutter. Your mileage may vary. I'm not really super sure of how well it works outside of Perlmutter, but that's what, but it was developed with the intention of streamlining this whole copying the image onto all the compute nodes process in order for users at NERSC to be able to use Podman to run their applications at scale. Coming to Apptainer. Apptainer creates a single file, so you don't have to deal with the same problems that Podman deals with multi-layered images. It just creates a single file that is stored on whatever file system that you have. And if you have GPFS or if you have Lustre, you store it there, and then when you're starting your job, across 1,000 nodes, all of those nodes can still see that single file, and you can start running a container from that single file. So it's quite a bit easier to manage compared to dealing with Podman images. So let's see. Another difference to note is that you have your multi-layered images in Podman, and you have your CIF files with Apptainer. A reasonable question is, why can't Podman build CIF files? Currently, the functionality isn't there, but it does have some limited support for running CIF files that you build with Apptainer, and kind of vice versa. Apptainer has support for taking images, OCI images that are stored on a registry or as a tar file locally, and then converting that to a CIF file in order to run the container. So you've seen the from key.io, this line where we're downloading the CentOS Stream 8 image from key.io. What this is doing, it is pulling an OCI image. That image was put there after being built with Docker and Podman. So Apptainer does have support to obtain and make use of OCI images. It just cannot, as far as I know, it cannot build an OCI image as its output. It can build a CIF file, but it can make use of other OCI images, but it cannot create OCI images that you can then store on a registry. And you can also, in addition to pulling images from a registry like key.io, you can also take a tar file that has been stored locally from, you can run podman save in order to convert a podman image into a tar file, and then Apptainer can take that tar file and run Apptainer build to produce a CIF file by specifying the Docker archive protocol and then the name of the tar file, and then that will actually create a working CIF file. And Podman has some limited support for, CIF files as well. So what that's basically doing is that it's taking a zip file and it's converting it back into the into the OCI image format, and then running that newly converted OCI image. It is not running, unlike Apptainer, which runs the zip file directly. It doesn't do any conversion. Podman first has to go through the process of doing the conversion, which is, the same steps that we described earlier, where you have to convert if you have a tar file, you convert that to a ordinary Podman image first before you run it. In the same way, Podman is doing that automatically with a zip file. It's taking the contents of the zip file, converting that into a Podman image before it starts running. So another thing that you'll encounter potentially is the need for sub-UID and sub-GID mappings for if you want to build some stuff, for some build capabilities with Podman, which is not really super required for Apptainer. So what are sub-UID, sub-GID mappings? So they are mappings that are present in /etc sub-UID and /etc sub-GID, where you map a user to a range of unused UIDs or a range of unused GIDs, starting from some starting UID value. In this case, you see Subil : starting UID value 4294705152, and starting from that UID up until starting from that UID to the next 65,536 UIDs, all those UIDs, and in the case of etc sub-GID, all those GIDs are now assigned to me to use as I please. So I can, outside of Podman, I can then use those UIDs to create files and create files with whose owners are these UIDs, and then manipulate those files as if I was using one of those UIDs myself. In the context of Podman, what Podman sometimes requires is being able to switch to some other UID when it's trying to during a container build process. This is particularly seen if you're trying to build a Ubuntu-based container image. Say, for example, you had an Ubuntu, you're pulling an Ubuntu container, and then you're trying to run apt-get to install some package. If you try to do that with Podman, without having sub-UID, sub-GIDs set, you will run into errors, because what Ubuntu is trying to do is that it's trying to change what apt-get is trying to do is that it's trying to change the group ID and the UID that it is trying to run with, but failing because it does not have access to any other UIDs or GIDs except the one that your user came with. But if you have these mappings, what Podman is able to do is that it's able to take those extra UIDs and map them to UID 0 through whatever within the container, so that from apt-get's perspective, it does in fact have access to 65,005. It does in fact have access to UID or GID number 65,534, and it will allow apt-get to complete correctly. So because of this, there are some, if you're trying to support Podman at your center, there are some images that you can build without requiring the sub-UID, sub-GID mappings, which is what we were doing for Summit. We say that only use CentOS because CentOS does not run into this issue, with some exceptions for some packages. So there are restrictions, right? If you don't want to place restrictions on your users, you will need to provide the sub-UID, sub-GID mappings. So there is a enterprise solution called FreeIPA that will help you maintain those mappings for all of your users. Otherwise, you're going to have to figure out some way of maintaining that in-house. And the effort of which will depend on how many users your center has, and if there are like ranges within that UID GID space that are reserved for one reason or purpose or other. And the ways to maintain them is like, if it's a small enough center, maybe you can maintain them by hand, where you're just updating them in whichever repository that's managing all the system configurations and then pushing them out to all of your compute nodes. Or if you have, if it's a much bigger center like NERSC, what they do is that they've integrated the sub-UID management to their account management software. And so all that gets automated and nobody has to manage it by hand. And so once you have the sub-UID mappings, the container build that we tried to do earlier will succeed because apt-get has access to those additional UIDs and GIDs that it wanted to have access to, and therefore it is able to continue its so that it is able to continue its tasks. So some things to note. Yes.
Subil, we have a question about the sub UID GID.
Yes.
Does Etsy? I'm gonna also post it in the chat so you can see it because there's some syntax involved. But does Etsy sub UID GID have to be on local disk, or can it be on a remote mounted file? So like
that's
NFS.
a good question. So I think you could do both. Like I don't know the answer to that myself because I don't work as a sysadmin necessarily. I think you would have to maintain it locally if you this is what I'm trying to remember from previous conversations with the people who are actually administrating these machines, is that you'd have to have it locally if you have a large number of compute nodes and they you have a large number of compute nodes, and if you're say for example you're trying to set up Etsy sub UID and C sub GID on NFS, and then you're mounting that NFS on all of those compute nodes. There's a possibility that might cause problems with NFS, and so it might be more beneficial if you instead make sure there's a separate copy on all of those local nodes. But ultimately, though, as long as the file is visible in Etsy sub UID sub GID, it doesn't matter. Podman will still be able to use it and still be able to make use of it. It's just it is up to the sysadmin to decide what kind of trickery that they can do in order to maintain it as a remote, whether or not they can maintain it as a remote mounted file.
Thank you. Yeah, and then whenever you're ready for the other questions, let us know.
Okay, I think I have a few more slides in this section, and then we'll go over the questions at the end of the section.
Awesome, thanks.
So good practices. So if you are an admin, be careful about reassigning the sub-UID GID mappings to a new user because the user can use those additional UIDs and GIDs as they please. They might have created files with those additional UIDs and GIDs. So if the mappings are, if user Bob had a set of mappings and he created some files with UIDs in that range, and then Bob leaves, and then the admin decides to reassign the mappings to user Clarence. Clarence now has ownership of all those files that Bob created with those UIDs. So that's something to be mindful of, whether or not that's a cause for security concern or if that's a data auditing concern. That's something you will have to decide based on the needs of your center and the policies of your center. And if you're somebody who's building containers, treat building applications in your containers the same way as if you're building applications natively. You would not have access to other UIDs when you're building an application that's running natively. Though, to the best of your efforts, avoid trying to rely on the existence of additional UIDs and GIDs that your application and your container can use. Actually, let's stop here and we'll take some of those questions.
Awesome. So first question, it's kind of a general question about containers. In containers, we have OS as well as applications, and in virtual machines, we can have OS and applications. So what is the difference between containers and virtual machines?
So virtual machines, you're adding an additional hardware emulation layer, and that slows things down significantly. Whereas with containers, what you're doing is this like putting a little cardboard box around your application, but your cardboard box has holes in it, and so it can still run. It can still run as if it is just another application. It's just that within that cardboard box, your application is things that it sees its own set of libraries. But also it is still making use of the underlying host's kernel. Whereas with a virtual machine, everything, including the kernel, is part of that virtual machine. And so there is an emulation layer where then the kernel part has to talk to the virtualization layer that then has to talk to the actual OS that is running on the host. And that adds overhead. And so containers let you still have some level of isolation, or rather, I should say, instead of saying isolation, some level of control over what libraries or applications can see, without really giving up performance.
Great. And I just added you as a co-host, so you should be able to see the Q&A if you'd like, or I can keep reading you questions. It's up to you.
I'm trying to see where the Q&A. Oh, there it is. Okay, there we go. When a software is so Yang Liu asks, when a software is installed from source, is it possible to enable optimization options for a particular architecture? Yes, that is something you absolutely can do, and that's where some of my caveats of like be careful about assuming containers are portable, because be careful about assuming containers are portable, because like once you start doing things like optimizations for a particular architecture, you're starting to tie your your container to that particular machine. And but if like if you're trying to get a container to run on two completely different architectures, that's you wouldn't be able to do that anyway with a regular application, so it doesn't super matter. But if there's like a particular version of an Intel CPU and there's a newer version of Intel CPU with specific optimization options, that might not be that container may not be as portable, because you're tying it to a particular set of optimizations. But you can still do it. It's still valuable, especially if you want good performance, and if those optimization options, if you move it from one x86 to a different x86 without those optimization options, and if it still works, then it shouldn't. I don't think it will affect you too much. Carl, I hope that answers the question. That was a little bit all over the place. We can go over it again if we need to. Carl Skipper asks, we use FreeIPA, but does sub-UID GID work via NIS2? I don't know the answer to that, Carl, because that's the side that I haven't really touched. We've discussed FreeIPA, but for Frontier, we're not using FreeIPA, and I don't think so Frontier uses SLES, which is open, which is derived, or which is relative to OpenSUSE. FreeIPA, as far as I understand, that's like a Red Hat thing, so we've not really used FreeIPA at all. So we just tried to sidestep the sub-GID conversation entirely and tried to find workarounds around that. So this is where I run into some of the limitations of what I know. Okay. Okay.
We have a question that's in the chat that I was trying to move to the Q&A, but unfortunately I don't have the ability to do that. So I'm just gonna.
Okay, so is it Roland Haas?
Yes.
So Roland Haas asks, for Apptainer with its images mounted via Fuse, do you have experience on how much slowdown that gives compared to native parallel file system? I haven't dug into that deeply. I want to say there was a paper about it, but I couldn't really tell you. From some of the smaller tests that I've done, I have not seen I have not seen that kind of like significant levels of slowdown. It seemed but I've only tested with like MPI OSU benchmarks, and for that I have not seen. I've seen performance was comparable to running natively. So, but I don't know if that's because I mounted. I don't know if I don't know if that's because I didn't mount via Fuse, or if like Fuse was not actually giving us any trouble, or I'm not super sure. Okay.
So, yeah, do you have how much do you have left in the talk, do you think?
So I have another, let's see, I think another 20 minutes.
20 minutes? Okay.
Yeah.
Yeah, let's do that. If there's a question that's relevant to like the slide that you're on, I'll ask it, but otherwise keep putting things in the chat. We'll do the rest of the questions at the end.
All right, cool. Sounds good. So another difference to talk about is I mentioned OCI registries and Podman creating OCI images, but Aptainer does not create OCI images. So OCI registries are the typical way that you will, oh, wait, that's not the slide that I wanted. OCI registries are the typical way that you distribute the container image that you built. If you build, and so if you built a container image and you want to make it available to the wider world or to a smaller group or whomever, you push it to an OCI registry by a command like podman push. And anyone who wants to use it can then pull that image from that registry in order for them to use it in their own system or for their own use case. And for Podman, it's able to push the image in its OCI form, whereas with Aptainer, since does not conform to the OCI structure, it needs to be stored. It needs to be stored as just an arbitrary file, and the way to do that is by using ORAS, which stands for OCI Registry as Storage. And several OCI registries have support for ORAS, so it's able to receive arbitrary software artifacts in addition to receiving OCI images. And so with Aptainer, you can run Aptainer push in order to store your CIF file you can store your CIF file within Docker, within the Docker registry, with the additional caveat that, or with the addition that you have to use this ORAS protocol if you're pushing a CIF file to the Docker Hub, and you're using a specific URL called registry-1 for Docker Hub. The URL that you push to will depend on the registry that you are using. And so what ORAS is basically a way for you to store arbitrary artifacts in an OCI registry. And so this allows you to distribute things that are not only OCI images through OCI registries. So after I push both of these, so in the previous slide, in this slide, I showed Podman push and an Aptainer push. So here you see at the bottom, you see the Podman OCI image, which is the Podman OCI image that I just pushed to Docker Hub. And up here, you see the CIF file, and you can see the type is indicated as artifact, showing that it is, a arbitrary file and not an OCI image. And we talked about, and where the distinction is important, right? And this also ties into the layered image format of Podman versus the single file format of Aptainer, is that when you push an OCI image, all of its individual layers are stored. So because the individual layers are stored, you can treat them as being cached. So what that means on the registry side is that if two different people have uploaded the same layer, they don't have to store two different copies of that same layer, because all the layers are identified by their hashes. And so if two different layers have the same hash, they have the same contents. You only need to store one copy of that particular layer. And this is useful for, Docker to save on their storage space. It's also useful for you or whomever is maintaining an internal registry within your HPC center, because you want to provide a way for your users to store OCI images somewhere within your HPC center for various reasons. Maybe there's security, maybe there's like proprietary reasons you don't want to push to Docker Hub. And so the layer structure helps there, because you're able to save on some space, especially if there's a number of different users that are working on small variations of the same image, and they all push and pull from the same registry. You're not using up a lot of space. Another useful thing about having multi-layered images versus having the single file format is build speed, because those intermediate layers are cached. If you make a small modification to your container file, and you want to rebuild it, you are not waiting the entire time for the entire container to build based on the full container file. It is able to, because the intermediate layers are cached, it is very, very quick to build the new image that was derived from the previous image. Whereas with Apptainer, if you make a small change to your definition file and you rebuild it, it's going to rebuild the whole thing. And so you see here, this was just a very quick measurement of me building a container image for the first time with Podman, and then without any modifications, I type in Podman build again. It's almost instantaneous. Whereas with Apptainer, since there is not any caching, I build it the first time, and when I build it again, since there's no caching, it takes the entire time to rebuild the whole thing fully. So talking about getting MPI and GPUs, working with your containers, this is where you start seeing you will start putting in the work to tie in specifics of your host MPI libraries into your container. And once you start tying your container more and more to your system, it becomes less and less portable, but with the trade-off that you get more and more performance. Again, so just another disclaimer, I'm primarily focusing on Apptainer in this section, since that's what we are using and encouraging our users to use as the runtime. I don't really have any experience with using Podman to run with MPI. So with Apptainer, there's two known concepts for running MPI applications with MPI applications from your container with Apptainer. There's the hybrid model, and then there's the bind model. So in the hybrid model, you have your container, and your container has your application that is linked to MPI libraries. And then when you start running the container, and if you launch the container with a job launcher like Slurm, it is able to communicate with the PMI interface, and is able to communicate with the communication infrastructure of the host and the host MPI libraries in order to perform any internode communication or any inter-process communication that you need to do. Maybe in a future iteration of this talk, I'll have a better explanation of what PMI is and PMI does. I just know that PMI is the thing that stands between, and it does some magic in order to allow the communication to happen. With bind model, the difference there is that instead of relying on the PMI interface that is set up by your job launcher, you are instead mounting the MPI libraries from the container. You're mounting the MPI libraries from the host into the container, and then relinking your application to use those host libraries directly, instead of going through the MPI libraries that was previously installed in your container. And so this has the advantage of instead of going through this interface, you're making use of the optimized MPI libraries. However, it does come at the cost of you're doing the extra work to figure out how to make this mounting correctly and how to make this linking correctly and how to make sure that it doesn't error out because you made a mistake. Whereas setting this up is a lot easier. It's a lot more plug and play than bind model is. So as an example, I'm going to go over, like, this is for later reference. I'm not super going to go into detail of the specifics of the container image that I'm using. The only important thing to know is that it's has mpitch 3.4.2 installed, and it has ROCm 5.5.1 installed, and it's running on Frontier. So in order to run with the hybrid model, I don't have to do anything super special. I just start my apptainer with apptainer exec. With apptainer exec, and I'm launching my job with srun with --npi pmi2 to set up the PMI interface, and it is able to perform MPI communication correctly. And if I look at the LDD output of my ping pong GPUaware.exe application, I will see that it is linked to libmpi.so.12, which is installed within my container. So this is the mpitch 3.4.2 that was installed in the container, and my application is relying on that. A great reason to use hybrid model is that you don't have to worry about binding MPI libraries, which can be a trial and error process, and it makes things a little bit more easy to move around. If your application isn't super concerned about really high speeds with MPI, hybrid model is an easy thing to pick up and use. With bind model, you are putting in a lot more effort because you're trying to bind in the MPI libraries into the container, and this is especially if you have a particular vendor that has a particular set of MPI libraries that are installed in certain locations, and all of those, and you need to make sure all of those are made visible inside the container in order for bind model to work correctly. And so since Frontier is a Cray machine, we have the Cray programming environment and Cray mpitch, which is derived from the open source mpitch that is provided by Argonne. All of those, the Cray mpitch libraries must be made visible inside the container. And so these environment variables that are highlighted help with that. So going over those one by one. So another thing to note is that if you're trying to support a set of users that are trying to do this, it may be easier to put all of these environment variables inside a module file so that it is invisible to the user and becomes easier for them to make use of the bind model without actually going through the confusing steps of setting up the bind model. If you've already done the work for them, this could be a script or something that they run before their application that will set up all of these environment variables based on whatever programming environment that they have. So going over the environment variables, what I will need for the bind model is the mounting of these directories into my container. And so that's what binds is. I'm specifying --bind, and all of these directories are now mounted into the running container when a container starts running. And you can see that the entirety of opt_cray, which is where all the mpitch and related libraries reside, the entirety of opt_cray is mounted and visible inside the container. Well, here I am setting up the LD library paths within the container. What apptainer n does is that whatever environment variable I have and whatever value I give it, those are set exactly as they are inside the running container. So if I set up apptainer n LD library path within the running container, if I look at LD library path, I will see these values. And as part of the LD library path, I need to make sure that the mpitch, the hosts, Cray mpitch libraries are visible in that LD library path. The containers opt ROCm, since I've installed my own ROCm inside the container. I need to make sure that those are part of the LD library path, since this will override whatever default LD library path was in the running container. You need to make sure that any additional libraries that should be part of any additional library locations that should be part of the search path is also written into the LD library. Is also written into this environment variable, since this replaces the LD library path inside the container. And so this has like additional, cray LD library path locations, the LD library path locations from the host, other cray stuff that were necessary in order for bind model to work correctly. Apptainer contain libs, what it does is that it takes specific libraries from specific locations. So specific libraries from the host user lib64 and make sure that those are those specific libraries are mounted into the container. So for example, libcxi does not exist inside the container, but libcxi is required for some of these cray and pitch library. So for some of these cray and pitch libraries to work correctly. So I'm making sure that that is mounted inside the container. And Apptainer and LD preload sets up the LD preload environment variable inside the container so that this library is preloaded for any application that is running. And this same thing is the same library is preloaded for all the applications that Frontier is running natively, because this has some MPI related optimizations that are necessary. And so this needs to be set up inside the container as well, because that's not going to be set up inside the container, because it's, it's a whole separate environment with its own separate set of environment variables. So I need to make sure that this is correctly set up inside the container in order for the application inside the container to make use of the cray and pitch libraries. So you see there's quite a bit of work that needs to be done in order for bind model to be set up correctly. And if I look at the LDD output for that application, excuse me, so when you see the LDD output for that application, you will see that libmpi.so.12 is now pointing to the cray mpitch library location instead of the mpitch library that I had installed inside my container image. And you'll also notice that there's a number of these additional auxiliary libraries that are required by the cray mpitch library. All of those are also, since I've done the work of binding those locations into the container, as well as making sure that these library locations are part of the LD library path environment variable, the application is able to search for and find and link to these libraries, and is actually able to work correctly and make use of the mpitch, the cray mpitch libraries. And also you'll notice that the libcxi.so, that one that I mounted with one of the environment variables, that is visible. So libcxi.so.1, that is part of user lib64 in the host, but in the container it is in .singularity.d/libs. And since that is like an individual library that I'm mounting in, Apptainer does some work to create this directory and put any additional libraries that I'm asking for in that location, as well as making sure that this location is appended to the LD library path so that the application can find it. And primary reason to use bind model, speed. It's a lot faster, especially with MPI, compared to the hybrid model. This is a chart showing performance for OSU all-to-all. This is a very quick test. They don't say this has a lot of scientific rigor, but there was a paper that we wrote a while ago whose graphs I couldn't find. That was a little bit more rigorous. That was for a different supercomputer, Gaia, that we manage for NOAA, that bore out the same results, where we showed that hybrid model is a lot slower compared to bind model when you're running MPI. When you're running MPI communications. And so it is beneficial for you to run your applications with the bind model when you are dealing with, when you are requiring good fast performance.
So we had a quick question. Yes. Maybe the answer is don't bother with hybrid model, just use the bind model. But Yang Yu is asking, for the hybrid model, does the MPI libraries in a container need to be built with the same PMIX, PMI lib event that are used to build Slurm on the host?
That's in the Q&A. Let me look
Yeah,
at the
it's at the bottom.
For the hybrid model, does the MPI libs in a container need to be built with the same PMIX, PMI lib events that are used to build Slurm on the host? I don't think so. At least that's not how it's been borne out for me. As long as the MPI libraries in the container are ABI compatible, that's what I was about to cover here. If they are ABI compatible with the version of MPI that is on the host, that is sufficient. I don't think you need the same. I don't think you need the exact same. You don't. You don't need the exact same libraries as that was used to build Slurm on the host. I think some of that is solved by some of the locations that I'm binding into the container so that it is actually visible, so that the mpitch libraries that I'm pulling from the host is able to actually see the PMI, PMIX libraries on the host. But I didn't have to do anything extra in order to build the MPI libs in the container with those specific PMI or PMIX libraries. At least not so far for mpitch. I don't know about OpenMPI and others as far as I remember.
And then there's one other, you may have answered it already, but it's the second question. What has been your experience with matching MPI versions from multiple cluster host level to MPI version within a built container as far as ABI compatibility and mpitch, OpenMPI, Cray MPI? So that might be what you're answering here.
Yeah, so that's a good question. So I can only speak for successfully having ABI compatibility for variants of mpitch. So there's, I think, an agreement between various vendors that develop MPI libraries that are based on mpitch to maintain ABI compatibility between them. I found that Argon's mpitch, I believe, I'm going to call the base mpitch as Argon's mpitch. Argon's mpitch and Cray mpitch are ABI compatible. I believe I've seen Argon mpitch and Intel MPI are ABI compatible. I cannot speak for OpenMPI because we don't really have. I believe it worked. I believe OpenMPI and mpitch can work if you're running the hybrid model. I have not super tested it with OpenMPI and I've not tested between OpenMPI and Cray mpitch or OpenMPI or any other mpitch because like it's easy enough to install mpitch in our containers just as it is easy enough to install with OpenMPI. You could reasonably, any application that works with one can reasonably work with another. So at that point, the advice is you tell your users to just use mpitch instead. So I can't really speak for like with any level of depth beyond what I just said about which ones are ABI compatible and which ones are not. So, but yeah, the gist of it is I know mpitch and Cray mpitch are in fact ABI compatible, and I think Cray mpitch and Intel MPI are in fact ABI compatible. And for versions, Cray mpitch is derived from 3.5.2 or mpitch 3.5.2. I think that's what I had here. 3.4.2, sorry. Cray mpitch is derived from 3.4.2. But I've also, in the container, I'll install mpitch 3.4.2, and that has worked successfully. I have installed mpitch 4.0.1 in the container, and that has still worked with Cray mpitch. So I think there is a little leeway in the version numbers that you can use when you're version numbers that you can use between the host and between the and the container, and those still seem to work. Again, right now, focus was on just making sure we stick as closely as possible to what was available on frontier, and so the best practice that we have in our documentation, or rather what we have for our images, is use mpitch 3.4.2. Okay. I think I'll head and have a ton more slides, so I think you'll be able to go to Q&A at the end of this. So, okay. So getting MPI working in your container for a HPC system. First thing to check, as with some of the discussions for the questions just now, check who your vendor is. The way you will get where you will find the MPI libraries and whether or not the MPI libraries will work and what MPI libraries are ABI compatible with which vendors' MPI libraries are going to depend on the vendor. What you will do for an IBM supercomputer is going to be different from what you will do from an HP Cray supercomputer. Another thing to check is if your MPI implementation is proprietary. Maybe you have a cluster that is entirely built with OpenMPI or entirely built with the base open source mpitch. In which case, great. You can use the exact same. You can when you're building your container, you can grab the exact same version of OpenMPI or mpitch, install that in your container. You can reasonably expect bind model to work very, very easily without a lot of twiddling around. When it comes to something like a proprietary version of mpitch, like Cray's mpitch, there's some level of there is an ABI compatibility between that and other mpitch, other variants of mpitch. And so you are able to still use bind model with some additional effort, like we saw earlier, where Cray HP has a lot of other auxiliary libraries that its MPI libraries need access to in order for them to work correctly. And if the MPI library on the host and the MPI library in your container are not ABI compatible, bind model will not work well or work at all, really. And so, again, my generalized takeaway is there will be trial and error. Try things out, see what will work and what doesn't, and then eventually you'll get to the point where you have something running and is running well, and then that's something you can disseminate to your users. So, as an example, talking about experiences with the machines that we have. For Spectrum MPI, which was installed on Summit, which is an IBM machine, my advice to you is to give up. And I'm kidding. It was a difficult process, just because like Spectrum, we didn't really have a lot of help from IBM in trying to get Spectrum MPI working with containers. Ultimately, what we ended up on is like we had to tie our containers very specifically to Summit. It was not going to be portable at all unless you were taking your container to a different IBM machine with the same Spectrum MPI versions installed. Because what we were doing is that we were binding MPI libraries from the host into the container during the container build process in order for the application to build correctly, making use of the Spectrum MPI libraries, which meant that we had to provide some base images with some hard-coded paths in the container pointing to the host MPI location that it will be able to access once you've mounted the host MPI location into the container. And bind mode is the only thing that we've found worked. I'm pretty sure I've tried with hybrid mode, or the hybrid model with Spectrum MPI, and it didn't work with everything I tried. If there's folks in the audience who do have experience with an IBM supercomputer working with Spectrum MPI and using containers with that, and you have succeeded, please let me know, and I am interested to hear what you did and how you succeeded. Talking about Cray mpitch as another example, Frontier is a Cray HPE machine. Hybrid model does work, but it's very slow, as we saw in the chart that I showed earlier. If you're using the bind model, make sure that all those other auxiliary pieces that Cray and Pitch's libraries are dependent on, make sure all of those are also mounted into your container. And that will take some trial and error. So I mount the entirety of opt-cray into the container because that was just the easiest thing to do. And the container doesn't have any Cray stuff at all. So doing that, it doesn't affect anything. And finding the correct libraries to mount in and finding the correct library locations to make sure that they're part of the LD library path inside the running container is going to take some trial and error, but it is doable. And then you eventually get to the point where bind model is working and is showing performance that is close to, if not the same as running natively. And the great thing about Cray and Pitch is that it can make use of the MPitch ABI compatibility, which means that different versions of different variants of MPitch have all agreed to maintain ABI compatibility between them. So if you build an application against plain old MPitch, you can use that application with Cray MPitch or with Intel MPI, and you can reasonably expect them to work even though that they are two separate libraries. So compared to MPI, getting GPU working with Apptainer is very easy. All you needed is a flag for --NV for NVIDIA or for NVIDIA GPUs and --ROCm for AMD GPUs. That mounts the GPU device files into the container. The GPU is visible inside the container, and it works well. There have been no troubles, and it works well also with GPU-aware MPI, where you have GPU specific data structures, and instead of staging them through the CPU, you're instead transporting or sending them directly without staging them through the CPU. That still also works when your application is containerized with Apptainer. Have not had issues, so that has been good. That has been a good experience. With Podman has a utility called NVIDIA Container Toolkit that gives containers or applications inside containers access to the NVIDIA GPUs on the host. I don't know what the status is. I don't know if there's an equivalent for that for AMD GPUs, but I know for NVIDIA GPUs that does exist, and I believe it works successfully. So one last thing to talk about is providing base images to your users. So all of this is a lot of work, right? And if you are supporting a set of users like I am as part of my group in OLCF, it is beneficial to your users to provide a set of base images with some, with some conveniences already installed as part of that image. So for example, for Summit, we provide a CentOS-based base image with GCC 8 and CUDA 11.7, and along with some MPI-related stuff that we provide to the users and tell the users, hey, start with this instead of trying to build your own. If you try to build your own, you will waste a lot of time trying to get things working. Here's something that already works, build on top of it, get to your science faster. So at the basic level, have the MPI libraries and any auxiliary MPI related things installed in your image, and then provide that, and that provides the absolute base that your users could build on. If you are a center that has a large population that is doing a particular thing, for example, there's a large population that is using lamps, it may be beneficial to build a container image that has lamps already installed and just provide that to the user, so they don't have to worry about or think about how to build that container image by themselves. And there are some centers that are starting to look at using containers directly when a user's load a module for a particular piece of software. It is invisible to the user that all the software is actually in a container form. They just module load something, and then they're actually placed inside a container, not realizing that they're inside a container. There was a paper at PERC last year from an admin or an engineer at Washington University, where they are doing exactly this. I believe Idaho National Lab is starting to explore doing exactly this, where everything is in a container, and so that for them, it is easier to manage than maintaining a set of modules and maintaining a software stack directly on the host. Instead, they're able to build up a bunch of containers that provides the software that they need. And then the users don't really care as long as they are able to get the stuff that they want to working. So that about brings me to the close. Some broad conclusions. Containers are useful for packaging up your HPC applications. They're not a panacea. There are many different container runtimes. So pick the one or ones that suit your needs or suit the user's needs that you are supporting. There is some portability that you can get out of containers, but that is traded off for performance. If you are trying to maximize the use of the HPC system that you have because you're making use of the host libraries from that HPC system. And if you're making use of those host libraries, there's going to be some trial and error involved while trying to get that container to run correctly on the host with those host libraries. And I thank you for the opportunity to speak at this in this tutorial and training series. It's been a great honor, and looking forward to hearing more. All right. Well, that's about it. Feel free to ask questions. Might be a good opportunity to go over the Q&A.
Yeah. So thank you so much, Subil. That was really good. I definitely took away, don't bother with hybrid, use the bind model, because I'm going to probably have to do more with containers soon. So I'm very excited to get that little bit of advice while I'm kind of running around, making sure stuff happens in the background. So what I'm going to do is folks can continue to put answers in the Q&A. We'll try to get to as many as we can. I'm going to put up a poll that we have for this, and we'll leave that up while we're doing the Q&A. And I'll do kind of my closing business stuff, and then we'll just save the rest of the time for Q&A. So let me put the poll up. Okay. And so this is just for feedback on the talk. There are some spaces for free response, but if you want to kind of take some more time to think about your free response, we do have a Google form, so you could put that in there instead and answer it later if you'd like. I'd like to remind everybody that the recording and slides will be available. We're going to post the links, or we regularly post links and recordings to materials for all the previous talks on this page here that I'm posting in the chat. So you'll see previous talks and this one pop up soon. And again, if you're not a member of USRSC and you'd like to become one, you can join on the USRSC webpage. And with that, let's get to some questions. Subil, do you want to go through and answer them, or do you want me to pick ones? And
you go ahead and pick ones. I don't know which ones came when, so I don't know how to prioritize.
I think they're in time order. So
okay.
So the one at the top is the earliest.
Okay. Okay. So Parikshit Nanda asks, do you have any thoughts on or experiences using SPAC Containerize? I do not. That is pretty much my answer. It sounds interesting. I don't know if others have. If they do, feel free to chime in, but I don't. Okay. Roland asks, that might be a comment.
I think that was a continuation of a conversation.
Okay, so I'll go over. Vinod Gupta asks, do the container images added to repositories undergo any security review? So that'll depend on. So I feel like there's some ambiguity to that question, so I'll try to answer both of what I'm hearing. So if you are maintaining your own repository in your HPC center, then it'll depend on the policies that your HPC center has about scanning the images that are being pushed to your internal registry. I believe Docker Hub, like some public registries like Docker Hub do perform security scanning to catch any vulnerabilities or like unupdated packages that need to be updated, right? And so you do get a warning when you push an image to a registry that hey, this needs to be updated by the please do the following actions. As far as, so does that answer your question, Vinod? If you're in the chat, like if you want to clarify, if that answers the question, because I'm not sure if I got the intent. Okay, great.
Yes. Yeah.
All right, Vinod says yes. All right. Next question, Yang Liu asks, is it possible to automate the installation of a software package in an Apptainer recipe that requires user interactions like selecting region, keyboard, etc.? Probably that, I suppose that depends on the package itself, right? If the package's install script has flags that you can specify, then that's the way to do it. If it's like, if you're monitoring, so if you're building with Apptainer, it will prompt you if there's like any yes or no. If there's like any yes or no, like enter keyboard or enter region here. If you're monitoring the Apptainer build, then yes, you will be able to see that. If you're like pushing it off to a CI/CD server, then you'll have to find out some way to fix those. Find out some way to predefine the answers for you. But if you're like, yeah, on your terminal in SSH, typing Apptainer build, whatever, it will ask you. So it's not going to error out for you or anything. If this is a graphical interface rather than a terminal interface, I don't know the answer to that. I have not encountered that when trying to build with Apptainer. So your mileage may vary there. Fang Liu asks how ORNL uses Podman and Apptainer together. What's the recommendation on choosing one versus the other? So previously, a couple of years ago, when we were getting container support for Summit, Singularity did not have the ability to build containers at all without sub-UID, sub-GID mappings. And we didn't have the ability to provide sub-UID, sub-GID mappings to all of those users. What we discovered at the time, and a lot of this has changed, right? That's why I had the comment where like I'm a couple of years out of date, and as I was preparing these slides, so I had to update my knowledge. What was present previously was because of those restrictions with building a image with Singularity, we had to use Podman instead to build our image, convert that to a Singularity format, and then use Singularity as our runtime to actually run the image. Now the choice is a little, now both of those have been updated. Like we're using Apptainer now, where you can build your image without needing sub-UID, sub-GID mappings. I believe so that's also where I don't have experience at all with running Podman images as the runtime, as like using Podman to run MPI-based applications in container form. I've only ever used Apptainer because Apptainer has been super easy. This is the answer to that. There might be reasons where you'd want to still support the ability to build Podman images, but because Apptainer is able to take an OCI image and convert it to CIF convert it to the CIF format and then run that, it is still Apptainer still ends up being the primary choice with which to run containers. The reason to support Podman, at least for us, is when we might encounter users who only have a container file, only have a Podman only have a file with which the reason to support Podman is only if they have a container file which has the instructions to build a container with Podman, and they don't have any other alternative. So we want to support Podman so that they're at least able to build their image and then instruct them on how to convert it to Apptainer so they can run it. right now, the easy choice if you are an HPC system and you don't have any other restrictions is to just go with Apptainer. That's really the recommendation that I have. I think things will change. I'm sure Red Hat has their eye on the HPC space. Maybe they'll have more support coming in the future. But yeah, we'll see what the future holds. Things change very quickly. Vinod Gupta asks, since container contains all the required libs or libraries, can container images potentially get very fat? Yes, absolutely. So if they can go in, I've seen container images go into multiple gigabytes because we're installing everything and the kitchen sink inside the container. So there was a for Summit where we are having to install a number of CUDA libraries. So I think that got up to a few gigabytes in size, and those are pretty big. Right, there's ways to reduce the size of the containers. One way you could do is that only install essential. You can have a container with the kitchen sink and everything installed, and then use that container image to build your application and then copy your application to a smaller container that only has the essential libraries installed. And that smaller container is much more, container image is much more manageable. However, if your application needs everything and the kitchen sink, then you kind of have to deal with a large container image. But that's I guess that's kind of the price that you pay sometimes in order to have everything in one box that you can carry around without having to worry about whether or not your host system has those libraries or not. I hope that answers Vinod's question. Cameron Rutherford asks, are you limited to OCI compliant? Oh, sorry.
Yeah, I'll just mention it is 3 o'clock my time. It's the end of the session. So if you want to maybe pick a last question to answer, or if you want to stay on longer to answer questions. I know some people probably have things they have to run off to do, but
yeah, I'm good with staying and continuing to answer questions, especially since this is being recorded. I'll just make sure that those are answered and available in the recording should people want to come back for that. As long as that's not an issue for Zoom or the organizers. All right.
I'm here, so.
Okay. So next question, Cameron Rutherford asks, are you limited to OCI compliant runtimes for providing base images, or can you use Apptainer or Singularity for providing base images as well? So right now, the answer to that will again depend on the center and the needs of your center and the needs of your users, right? At least here for Frontier, we're providing base images in zip file format, like Asa, one of my colleagues who was in the chat earlier, he's working on creating those base images. And we're providing that we're providing those base images that they're currently stored on the file system somewhere. And in our instructions, in our documentation, we can say, here are the instructions on how to build your image from these base images. If at some point in the future we start providing support for Podman, we'll be able to start building base images in Podman's format, that is in the OCI compliant format, so that users can build their own images derived from those OCI compliant base images. But that's in the future. But again, yeah, that's the answer to that is, for us, it's right now, we're doing everything with Apptainer. For you or whomever is maintaining an HPC system and an HPC center somewhere, it will depend on the specifics of your users and what you are willing to support. Vinod Gupta asks, what is the plan for CentOS replacement on Summit? I'm not sure I understand that question. I'll move on from that. Vinod, if you're in the chat, still feel free to chime in, because otherwise we'll continue to the next one.
Vinod has left, but I think probably a lot of centers are replacing CentOS just because of the way it's supported these days. So I think
Okay.
the question was on maybe not so much Summit, but like future systems.
Oh, sure. Yeah. So for
And
Summit, at
that's
least for, yeah, at
a
least for
tough question.
yeah, for base images, at least like Summit is, and it's not, it's not expected to have a very long life further on. So I think we'll still be within, time of like CentOS support. And with, we're not super worried, at least for me, we're not super worried about like CentOS images running on, within Summit, just because like it's not exposed to the world. So even if it's drop support, as long as it still does the job, and as long as the image is able to, as long as container is able to do the job within, when it's launched with the job scheduler and so on, it's, as long as it does the job, it doesn't super, I don't think it super matters whether or not we have to tell the users to update their base images so that it's using a newer version of CentOS. If it's a publicly, there's work being done by folks in infrastructure and to update the CentOS versions that that are publicly facing. But that's different, and that's something I don't really have any information on. But for containers, since it's all contained, since it all exists only within the scope of running inside Summit, it's not a huge issue. Because like even for Summit, at least the policy is that we're not sharing nodes. Like once a job is launched on a node, it's exclusive to that user. So there's not any chance of like two users sharing the same node and then like interfering or like one exploiting a security issue or anything like that. Fang Liu asks, any interest on building an Aptainer container registry across multiple HPC centers? I don't know the answer to that. I'm sure there's a lot of interest. I cannot speak for whether or not if there's like any current ongoing efforts. If there is an effort, please let me know. I can pass that on to folks who are interested within Oak Ridge who want to hear more about that. Anonymous participant asks, on the slide titled, "Why should you use bind model? What are the units on the X and Y axis?" So let me go back to that. So the x-axis, the x-axis is the size this is the message size. So this is message size for the OSU all-to-all benchmark. So this is in bytes, so 1 byte, 2 byte, 4 byte, 8 bytes, and this is milliseconds. Milliseconds or microseconds. I'm so sorry. It's whatever the output for OSU all-to-all is. Not remembering off the top of my head. I really should have added the y-axis there, but that's time is what I should say. Anonymous participant asks, should users be allowed to build containers on HPC? I thought there were security concerns with building. I think users should be allowed to build containers on HPC. It is because that's really for a lot of cases, there's really the only place that they can build their containers. If you're getting to the point, this again depends on the security posture of your HPC center, right? If the HPC center has determined that a user should be allowed to run containers on the HPC system, be it Frontier or Summit or whatever your HPC system is, they should also be allowed to build containers on HPC, because there might be cases where they don't have the matching architecture somewhere else where they can build their containers and then bring it over to the HPC system. And I don't believe there's any security concerns with building containers, no more than there would be security concerns with letting your users build, any old arbitrary application. If there are restrictions on what applications the users can build on your HPC system, that will of course cascade onto what applications can be built in the containers that they're building on HPC systems. But in general, I don't think there's any security concerns.
I think it requires some elevated privileges in order to do it, unless you're doing something.
No, not necessarily, not anymore, especially
Not
with things
anymore,
like
the newer ones. Yeah, but I think you have to like add extra features to it in order to do that. So, right?
No, not see, not anymore. That's previously you needed to with trying to remember. So Apptainer previously required something called SUID.
Yeah.
In order to allow it to, in order for users to be able to build containers, which did have like a privileged, an additional, like a brief privileged aspect to it. That is no longer required as long as you have Linux user namespaces, and those are completely unprivileged. And so that's really not an issue anymore for building. If you don't have Linux user namespaces, then you need the Apptainer SUID, which does have like which does do a little bit of privilege escalation, but it's for the most part it's not an issue. James Carpenter, do you have any thoughts or advice on using multi-stage builds with Apptainer? So for multi-stage builds with Apptainer, I don't super have a lot of experience, not enough to have any generally applicable advice. I know they're useful, and I encourage you to try it. And that's about all I have. Cameron Rutherford. Oh, sorry, anonymous participant. Oh wait, I already answered that, I think. Sorry, on the slide title, why you should use bind model.
Yeah. They're asking
Cameron,
what the units are on the X and Y axis.
yeah. So
Oh,
that's what
okay.
I was. Yeah, that's
Yeah.
what I said here. This is the x-axis is the message size. The y-axis is time. I forget that was milliseconds or microseconds. Cameron Rutherford asks, can you provide reference material on using Singularity Apptainer images as base images? I'm struggling to find any documentation about this, but I was under the impression only OCI images work as base images. That's not no, that's not true. You can use the CIF files that you create as base images. Let me exit out of this very quickly. Oh, there we go. It's easier if I can find one of the examples that I have here. Oh, we go further back. Not that one. This one? Sure, let's use this one. So instead of, here we have Bootstrap Docker, and we're downloading the OCI image for CentOS Stream 8 from key.io. So instead, if you want to instead use a locally created CIF file, so say, for example, you created the myCentOS.cif has been created somewhere, right? And you want to use that as your base image for whatever new image that you want to create on top of that. So what you would do here instead is that instead of for Bootstrap, you would specify local image, and then from you will specify the path to myCentOS.cif, and then in post you will do whatever things that you want, echo, hello, file A, let's say. And so that's what you need pretty much. That's how you can use a local image, a locally available CIF file that you created earlier as your base image, on top of which you can build a new image.